Hello and welcome back to Engineers Olympiad. We are doing the numerical questions for the topic weight volume relationships in geotechnical engineering. We have uploaded many videos on this channel. You can watch those videos before watching this video. So let's get started. Question is, a fully saturated clay has a mass of 130 grams and has a volume of 64 cc. The sample mass is 105 grams after oven drying. Assuming that the volume does not change during drying, determine the specific gravity of soil solids, void ratio, porosity, and the dry density. All right, so let's solve this question. First, we'll find the water content. All right, since the sample was oven dried, let's find the water content first. Let's read the question once again. A fully saturated clay has a mass of 130 grams and a volume of this much. The sample mass is this much after oven drying. So the water content is, this was mass before when it was in moist state. This is the mass after oven drying. So let's find the water content first. Water content will be 130 minus 105 divided by 105 grams. 130 minus 105. This was the mass in wet or moist state. This was the mass after it was dried in an oven. We'll be finding the water content first. So water content is how much? By calculations, it's 23.80%. All right. Thereafter, the first thing or the parameter that the question demands is the specific gravity of the soil solids. So let's find this specific gravity of the soil solids. Specific gravity denoted by G is equal to mass of soil solids divided by volume of solids multiplied by the density of the water. All right, let's go on substituting the values. But for that, we know this, but this parameter needs to be found out. That is volume of soil solids. Let's get back to the question and see what data has been provided. A fully saturated clay has a mass of this much and a volume of 64 cubic centimeters. So the volume is 64 cubic centimeter. All right. So we have to find this out. All right. So this is the total volume, but we need the volume of soil solids. For that, volume of solids will be total volume minus volume of voids. But in this case, as you can see, the question itself says that it is a fully saturated clay. That means all the voids are only filled with water and there is no air phase. That means here in this equation, I can substitute that volume of solids is total volume minus volume of water. All right. Why? Because the given soil sample is fully saturated. There is no air phase, only there is water in the voids. So I can say all the voids are completely filled with water only because soil is completely saturated and there is no air phase. All right. So the next step is to find this much because our aim is to find the specific gravity. For that, we need to use this equation. In this equation, we know this thing, but we don't know the volume of the soil solids. For that, we have to use this equation. We know the total volume. Now we have to find this volume of water. See, what was the mass of this sample? Before oven drying, it was 130 grams. What was mass of this soil sample after oven drying? It was 105 grams. So what does that mean? How much was the mass of water? This minus this, that is 25 grams. All right. So That's how I'll be finding my volume of water. As we know, volume of water, this is mass of water divided by density of water. Mass is how much? 25 grams. Density is how much? 1 gram per cc. Alright, so the volume of water is 25 centimeter cube or 25 cc, correct? Alright, students, so kindly take notes, and this is how we have arrived at the volume of water in this case. Alright, we're trying to solve as many questions as possible. That's how we'll be good enough in this topic. That is the weight volume relationships in geotechnical engineering. Alright, so we have found this thing. Now we can very easily find the volume of solids. Now, volume of solids is total volume minus volume of water. Total volume was how much, or is how much rather? 64 cc minus this is 25 cc, so it is 39 cubic centimeter. All right, we have used density of water as 1 gram per cc. Now we can find the first parameter that the question demands to find is the specific gravity of soil solids. Coming back to this equation, this one, specific gravity or G, it is equal to ms divided by volume multiplied by density of water. Mass of soil solids is how much? 1 to 5 grams. In wet state, its mass was this much. After oven drying, this is this much. That means mass of soil solids is 105 grams. 105 divided by volume is 39. We just calculated. Multiplied by density of water, 1 gram per cc. Please keep in mind the dimensional homogeneity. In solving numericals, you must take very care of the dimensional homogeneity. Alright. So after calculations, the value of specific gravity, it comes out to be 2.69. So that's how we arrived at the specific gravity of soil solids. Alright, and with that, the parameter number 1 is done. We have found the specific gravity of the soil solids, and that's equal to how much? 2.69. Next thing we need to find is the void ratio. Void ratio, denoted by E, is a ratio between volume of voids divided by volume of solids. Volume of voids in this case is the volume of water, since soil is the fully saturated condition, so it's 25 cc. Volume of soil solids is how much? 39. By calculations, void ratio is equal to 0.641. Alright, part number 2 is done as well. Now, porosity. We can very easily find porosity. We can use this equation, n is equal to E divided by 1 plus E. We already know E, we can find n. Or we can use this equation, porosity is volume of voids divided by total volume. Volume of voids is how much? That is volume of water in this case, 25. Total volume is how much? 64 cc. By calculations, it is equal to 39.1%, because we usually report porosity in terms of percentage. Alright, or alternatively, we can use this equation. We know this E, so n will become 0.641 divided by 1.641, which is equal to, let me calculate and find it out. We can use two different methods to find the porosity. 0.641 divided by 1.641 multiplied by 100, it is 39.06. Alright, so we can use either of the methods, or the equations rather, to find the porosity. Alright, so the third parameter has been found as well. Now we need to find dry density, and that's the last thing that we need to find, dry density. All right. Dry density is mass divided by volume. But which mass? Mass of the soil solids. That is mass of the soil in the dried condition. All right. And we know that the mass of the soil solids after it was subjected to oven drying is how much? 105 grams. So 105 divided by volume. Total volume of the sample is 64 cc. By calculation, this dry density is equal to 1.64 grams per centimeter cube. Now we can write 1.64 gram per cc. All right, so we have completed this question. We have found the values of all the four parameters that the question demanded us to find. All right, we have found the specific gravity, void ratio, porosity as dry density as well. All right, moving on to the next one. Next question is, a sample of clay having a mass of 675 grams was coated with paraffin wax. The combined mass of the clay and the wax was found to be 682 grams. The volume of this sample, I think I have missed something in here in the question. The volume was found by immersion. The volume, no, I have not missed anything. All right. The volume was found by immersion in water as 345 milliliters. The sample was then broken open and the water content and the specific gravity of solids were found out to be 15% and 2.70 respectively. Calculate the bulk density of soil, its void ratio and the degree of saturation. Take specific gravity of wax as 0.89. All right, we have to find the bulk density. All right, so this question, this is based on the data as found by the water displacement method, by which we find the bulk density. All right, the volume of the specimen is determined in this method by water displacement, and the soil mass, it disintegrates when it comes into contact with water, but the sample is coated with paraffin wax to make it impervious. All right, so this question is based on that method. All right, so let's solve this. Mass of wax, we'll find it first. Mass of wax. See carefully what is given in the question. A sample of clay having a mass of 675 grams was coated with paraffin wax. So this is combined mass of the clay and the wax was found out to be 682. So the mass of wax is 682 minus 675 grams. 682 minus 675. All right, which is equal to how much? 7 grams. 7 grams is the mass of the wax. All right. Why so? Because in this method, the sample of clay was taken, which was having a mass of 675 grams, and it was coated with paraffin wax to make it impervious. And then the combined mass of the clay and the wax was found out to be 682 grams. So the mass of the wax is 7 grams. All right. Now we'll find the volume of this wax. Volume of wax, let me denote it by V wax. This is how much? Mass of wax divided by specific gravity of wax multiplied by the density of the water. Volume of wax, mass of wax is how much? It's 7 grams divided by specific gravity but of wax. Take specific gravity of wax as 0.89. So here it is 0.89 multiplied with density of water, that is 1 gram per cc or 1 gram per milliliter. All right, so by calculations it's equal to 7.865 milliliters. All right, now we'll find the volume of soil. Volume of soil is how much? Let's get back to the data as given. All right, A sample of clay was taken, which was this much, and it was coated with paraffin wax to make it impervious, and the combined mass was this much. All right. Then the question says the volume was found by immersion in water as 345 milliliters. All right. So volume as found by the immersion in water was 345 milliliters. That means volume of soil will be 345 milliliters minus volume of this, total volume minus volume of wax. This is the total volume as it was found by the immersion in water. The volume came out to be 345 milliliters. We know the volume of wax as well, that is 7.865 milliliters. So the volume of soil is how much? 337.135 milliliters. All right, students, pay attention to the details as given in the question. It was found, the volume as found by the immersion water was 345 milliliters. That means the combined volume of this this clay plus paraffin wax. But we calculated the volume of paraffin wax separately and it came out equivalent to 7.865 milliliters. So the volume of soil will be the total volume that was found by immersion in water minus the volume of wax. So that is this much. All right. So the bulk density is how much? Bulk density is mass per unit volume. How much is the mass? 675 grams. This is without coating it with clay. All right, we have to take that parameter. We just coat this soil sample in this water displacement method by the paraffin wax so that when the soil mass comes in contact with the water, it should not disintegrate. That's why we coat it with paraffin wax to make it impervious. All right. So while calculating the bulk density, I'll take the volume of the clay sample. All right, without taking into consideration the mass of paraffin wax. All right, so the bulk density will be mass per unit volume. Mass is how much? The initial volume of the soil sample that was taken for this water displacement method, that is 675 grams. 675 divided by volume of soil, obviously without the wax part, 337.135. By calculations, my bulk density is 2 grams per milliliter. Let's get back to the question and see what else it demands. Calculate the bulk density of the soil. That we have done. Its void ratio and degree of saturation. That means two things we need to find out. Now that is void ratio and the degree of saturation. For void ratio, I'll find dry density first. Dry density is bulk density divided by 1 plus water content. I have found out the water content initially, I think. No, I have not. Oh, it's given in the question. All right. Here, the sample was then broken open and the water content and the specific gravity of solids were found out to be separately. Then it would be taken for oven drying method, or maybe specific gravity may be found out by the pycnometer method after the determination of the after water displacement method to find out the mass density or the bulk density. Then the sample of clay, which initially weighed 675 grams, and after immersion method it would have been separately taken for some other method to determine the water content and the specific gravity. Maybe it would be the own drying method or the pycnometer method for the specific gravity. All right, and then those parameters were separately found out to be 15% was the water content and 2.70 was the specific gravity. All right, we'll be using these parameters. So the bulk density is 2. We have just found its value. Divided by 1 plus water content is 15%. All right, by calculations, my dry density is 1.73 grams per milliliter. Pay attention to the data as given in the question. This was subjected, or I'll say this was initially based on the water displacement method for finding the bulk density or the mass density. Then the sample was subsequently taken for some other test to find the water content and the specific gravity as well. All right, so I have found the dry density. Now my aim is to find actually the void ratio. I'll be using another alternate equation of dry density, that is G rho W 1 plus E. G of soil solids, 2.70. Density, 1 gram per cc or per milliliter, divided by 1 plus E. Here I'll be substituting this value. I already know the value of dry density. I'll be using this. All right. So dry density is 1.73. 1.73 grams per milliliter. All right. This is equal to 2.70 divided by 1 plus E. Or 1 plus E is equal to how much? It is 1.56. That means void ratio is 0.56. All right, we have found out the next parameter that the question demanded us to find. So we have calculated void ratio as well. We have calculated the bulk density, we have calculated the void ratio. Now the last thing that needs to be found is the degree of saturation. We can very easily do it. Degree of saturation, we'll use the general equation. ES is equal to WG. That means S is equal to W G divided by E. So degree of saturation is water content, 15%. Specific gravity of soil solids, obviously not of the wax, 2.70. Void ratio, we just calculated, 0.56. Alright, so by calculations, degree of saturation is equal to 72.3%. So we have completed this question. In all respects, we have found the bulk density, tick, void ratio, tick, degree of saturation as well. Alright, so this was the question. It was based on the water displacement method and we found out all the parameters. Alright, moving on to the next one. Alright, next question is, a soil has a bulk density of 1.80 grams per cubic centimeter at a water content of 5%. If the void ratio remains constant, then the bulk density for a water content of 10% will be. Alright, so let's solve this question. Alright, so let's solve it. Question says a soil has a bulk density of this much at a water content of this much. If the void ratio remains constant, then the bulk density for a water content of this much will be. First thing, we'll find the dry density. Dry density is bulk density divided by 1 plus water content. We know bulk density is how much? 1.80 and the water content is initially 5%. So the dry density is bulk density 1.80 gram per cubic centimeter divided by 1 plus water content. Water content is 5%. Alright, by calculations, dry density is equal to 1.71 grams per cubic centimeter. Alright, so this is the dry density, but this is not our goal. The question asks us to find if the void ratio remains constant, then the bulk density for a water content of 10% will be. If the void ratio remains constant, then the bulk density for a water content of 10% will be. Bulk density for a water content of 5% is this much. If the void ratio remains constant, we have to find the bulk density for a water content of 10%. Alright, since first I found the value of dry density based on the initial bulk density at a water content of 5%. Alright, since the void ratio remains constant, listen carefully, since the void ratio remains constant, dry density also remains constant. Not the bulk one, the dry one. Since the void ratio remains constant, the dry density also remains constant. It would not remain constant if this thing would have changed, but since the question itself says that the void ratio remains constant, that means the dry density also remains constant irrespective of any water content. Alright, so the dry density will be same. Now I have to find the bulk density for a water content of 10%. I'll be using the same equation. Dry density is bulk density divided by 1 plus water content. Since the white ratio remains constant, dry density remains constant. It will remain constant across all the water content. So for a water content of 5%, it was, and a bulk density of this much, it was, dry density was 1.71. White ratio is constant, that means dry density will also remain constant. So I'll be using the same value here, 1.71, as we found out. Now I'll be finding the new bulk density at a new water content of 10%. All right. By calculations, bulk density at a water content of 10% is 1.881 grams per cubic centimeter. So this is what question asked us to find. All right. So the bulk density of the same soil, if its white ratio remains constant at a water content of 10%, is 1.881 grams per cubic centimeter. Initially, at a water content of 5%, it was 1.80 grams per centimeter cube. All right. I use the same equation. Why so? Because if the white ratio remains constant, the dry density also remains constant. All right. I can use one shortcut formula which we use in competitive exams for solving such questions. This shortcut avoids calculating the dry density separately and is commonly used in competitive exams. All right. Shortcut formula is, you need not to find the dry density separately by using this formula. This is a shortcut formula. Bulk density 2 divided by 1 is 1 plus W2 divided by 1 plus W1. This is the shortcut formula that we use in competitive exams, and this avoids the need to find the dry density separately. We have to find the bulk density 2. Initial bulk density was how much? 1.80 grams per cubic centimeter. W2 at a second water content, it was 10%. Initial water content 5%. After calculations, bulk density is 1.885 grams per centimeter cube. So this is the alternative way of solving this question, by using the shortcut formula, as we use such formulas in competitive exams where we need to hurry up. We have limited time for each and every question. There we can use this shortcut formula and arrive at the bulk density at a different water content. Alright, if the white ratio remains constant. Alright, so we have completed this question. Now we'll be doing the next one. Moving on. Next question is, a soil sample with specific gravity of solids 2.70 has a mass specific gravity of 1.84. Assuming the soil to be perfectly dry, determine the white ratio. Alright, so let's solve this. Question says, a soil sample with specific gravity of solids at this much has a mass specific gravity of 1.84. Assuming the soil to be perfectly dry, determine the white ratio. Alright, mass specific gravity, we denote it by G subscript M. This is bulk density, or the density of soil, I'll say, divided by density of water. But here in this question, the question itself says, assuming the soil to be perfectly dry. So I replace this by dry density divided by water. Is how much? It's 1.84. That means this parameter is how much? Mass specific gravity, 1.84. The dry density of the soil, because the question itself, it says, assume the soil to be perfectly dry. It is 1.84 multiplied by density of water, which happens to be 1 gram per cubic centimeters. That means 1.84 multiplied by 1. It is dry density will be 1.84 grams per cc. Alright. So the question had the value of mass specific gravity of the soil as 1.84. We know that mass specific gravity is density of soil divided by density of the water. But in this case, in the question itself, it says, assume the soil to be perfectly dry. I replace this density by the dry density, and that's how I arrived at the dry density of the soil sample, which is equivalent to 1.84 grams per cc. But the question says, determine the void ratio. We have to determine the void ratio. I know the dry density. How did I arrive at it? By having this value of mass specific gravity. Now I have the dry density. I have to find the void ratio. I can very easily use the generalized equation for the dry density. Dry density is equal to G rho W 1 plus E. So dry density is, specific gravity is given. A soil sample with specific gravity of solids as 2.70. 2.70, density of water 1 grams per cc divided by 1 plus E. I know this. I'll be substituting this value 1.84. So 1.84 grams per cc is equal to 2.70 divided by 1 plus E, or 1 plus E is equal to how much? 1.467. So by calculations, E is equal to 0.467, or approximately I can say 0.47. So this was very interesting question. We had been given the value of mass specific gravity of soil solids. We had to, and there was an assumption that helped us to arrive at this parameter. The assumption was we had to assume the soil was perfectly dry, and we had to determine the void ratio, and that's how I determined the void ratio. All right, moving on to the next question. All right, the next question is a partially saturated sample from a borrow pit. The sample has been collected from a borrow pit that is in partially saturated condition, has a natural moisture content of 15%, and a bulk unit weight of 1.9 gram per cc. The specific gravity of solids is 2.70. We have to determine the degree of saturation and void ratio. The next part says what will be the unit weight of the sample on saturation. All right, so one by one we'll be solving this question. Let's solve the part first. Part A first. All right. All right, so let's have a quick look at the data given. Soil has a natural moisture content of 15% and a bulk unit weight of 1.9 gram per cc. Let's find the dry unit weight first. Dry unit weight is bulk unit weight divided by 1 plus water content. Dry unit weight is bulk unit weight is how much? 1.9 grams per cc. Over here, 1.9 gram per cc. 1 plus water content. The sample which was collected from the borrow pit, which is initially in a partially saturated condition, has a natural moisture content of 15%. All right, 0.15. By calculation, the dry unit weight is equal to 1.65 grams per cc. All right, I can use the alternate equation and I'll be having my void ratio. Let's see what the question says. Okay, degree of saturation and void ratio. Let's arrive at void ratio first. I know the dry unit weight. I'll be applying the alternative equation to find the water, to find this void ratio. Yeah. All right. 1 plus E. Dry unit weight 1.65 grams per cc. Specific gravity of soil solids we have to use as 2.70. Density of water 1 gram per cc. 1 plus E. That means 1 plus E is equal to 2.70 divided by 1.65, and E, after calculations, it's equal to 0.63. So we have found void ratio. Next thing that the question says us is degree of saturation. We know E, we know W, we know G. We can very easily be using this equation. ES is equal to WG, and we'll be arriving at degree of saturation, WG divided by E. Water content, how much? 15%. G, 2.70. Void ratio, 0.63. By calculations, degree of saturation is 64.28%. All right, degree of saturation is 64.28%. After that, I think with this, we completed the first part of the question, which was to find out the degree of saturation and white ratio. Now the question says, this is the second part, what will be the unit weight of the sample on saturation? That means we have to find the saturated unit weight. The unit weight of the sample on saturation is equal to saturated unit weight, which is given by the generalized equation G plus E 1 plus E. Saturated is G 2.70. White ratio, we found how much was white ratio, 0.63. Density of water, 1 gram per milliliter, 1 gram per cc divided by 1 plus E. That means E is 0.63, that is 1.63. By calculations, saturated unit weight is 2.04 gram per cc. We completed the question in all respects. We found out the degree of saturation, the white ratio, and also the unit weight of the sample on the saturation, that is the saturated unit weight. All right, so that's how we solve this question. Moving on to the next one. All right. Next question is, the natural water content of a sand sample is 20%, the bulk unit weight being 1.8 grams per cc. Assuming specific gravity of solids as 2.65 and the sand sample to be partially saturated, calculate the degree of saturation and the white ratio of the sample. All right, so let's solve this. Let's have a quick look at the parameters given. The natural water content is this much and the bulk unit weight is this much. So I'll be finding the dry unit weight first. Dry unit weight is given by bulk unit weight 1 plus water content. Dry unit weight is bulk unit weight is how much, 1.8 grams per cc divided by water content is 20%, 0.20. By calculations, dry unit weight is 1.5 grams per cc. 1.5 grams per cc. All right. Question says to find the degree of saturation and the white ratio. All right. Since I know the dry unit weight, I can use the alternative equation, that is dry unit weight is G 1 plus E, and I'll be arriving at the white ratio. This I'll be using here 1.5, specific gravity of soil solids 2.65. It's given in question. Assuming specific gravity of solids as 2.65. So I have assumed the same thing. Unit weight of water 1 gram per cc, 1 plus E. So by calculations, E is equal to 0.76. All right, E is equal to 0.76. So we have found the white ratio. Now we need to find the degree of saturation, which is equal to Wg divided by E. Water content is how much? 20%. Specific gravity, we have to use 2.65. White ratio is 0.76. So degree of saturation by calculations is 69.73%. All right, 69.73%. It was a very easy question, a short one and a very easy one. We had the natural water content of the soil, which is 20%. We had the bulk unit weight. We found the dry unit weight first, and then we used the alternate equation of dry unit weight, and we subsequently arrived at this white ratio thing, and then to degree of saturation. It was a very easy question. Let's move on to the next one. Next question is, a sample of saturated clay weighs 15.45 grams and its moisture content is 38%. If the particle specific gravity is 2.70, find the white ratio, porosity, dry and bulk unit weight of the soil. All right, so let's solve this question. This is a sample of saturated clay. That means S is 1. And it has a water content of 38%. Alright, specific gravity is also given 2.70. Let me use this equation. ES is equal to WG. I'll be arriving at wide ratio first. WG divided by S, sorry. So E is water content was how much? 38%, 0.38. G has been given as 2.70. 2.70 divided by S. S is 1 because question itself says a sample of saturated clay. There is no air phase, it's completely saturated, all the voids are filled with water. So S is 1. By calculations, void ratio is equal to 1.026. So we have completed the first part, void ratio. Now we need to find the porosity, dry and bulk unit weight. When we know the void ratio, we can easily use this equation and find the porosity, E divided by 1 plus E. This is 1.026 divided by 2.026. It is equal to 50.64% porosity. Now, dry and the bulk unit weight. Dry unit weight is equal to, by formula, generalized formula, this is this much, alright. So I can be substituting the values of this, this and this. I'll be having my dry unit weight. Dry unit weight is equal to specific gravity 2.70, density of water 1 gram per milliliter or 1 gram per cc, and 1 plus E is 1.026. So 1 plus 1.2026 is 2.026. So dry unit weight is 1.33 grams per cc. The last thing that we need to find is the bulk unit weight. I'll be using this formula, the one which relates the dry unit weight and the bulk unit weight and the water content. So dry unit weight 1.33. Bulk unit weight, we need to find water content, we know 38%. By calculations, the bulk unit weight is 1.84 grams per cc. Alright, so we completed the question in all respects. We found the void ratio, the porosity, the dry and the bulk unit weight. Alright, moving on to the next one. Alright, so this is the next question. Question is, the weight of an undried specimen of clay was 34.62 grams. The oven dry weight of the same specimen was 20.35 grams. Before drying, the specimen was immersed in mercury and its volume was found out to be 24.26 cubic centimeters. Calculate the water content, void ratio, degree of saturation of this soil, and assume the specific gravity of solids as 2.68. Let's find, alright, the value that the question asks us to find. Alright, so this is again data, data, it is based upon the displacement method to find out the bulk density or the mass density. Now, this sample, this was in moist condition first and it was dried and the weights were changed. The first question we need to find is, in the previous question it was first it was subjected to the water displacement method and then it was subsequently taken for some method for determination of water content. Let's suppose oven dry method. In this question the data says that first the sample was oven dried, right? Then it was subjected to the, then it was immersed in mercury to find the volume extra so that we can arrive at mass density and bulk density thing. All right, let's solve it. First we'll find the water content because we know the mass of undried specimen, we know the weight after drying, we can very easily find the water content. Water content is initial weight or the weight in the bulk or the moist condition or the wet condition, whatever you can say, is 34.62 grams. 34.62. This 34.62 is the initial weight of an undried specimen of clay. So the water content is 34.62 minus this much, the oven dry weight, 20.35 divided by 20.35. By calculations, water content is equal to 70.12%. All right. Let's calculate the water content. Water content thing is done. Now we have to calculate the void ratio. For that, I'll be calculating the dry unit weight first. All right. And then subsequently, we'll be arriving at the void ratio. See how? I know the water content. I'll be finding this dry unit weight. This is bulk divided by how much? I think it's pretty easy for us to use alternative thing. We'll be finding the volume of solids first. It's quite easy. Volume of solids is weight of solids divided by density of water and the specific gravity of soil solids. Weight is how much? This much. This is the oven dry weight. So this is the weight of solids. It's 20.35. Specific gravity, question says assume specific gravity of soil solids as 2.68. This thing we know it's 1 gram per cc. So volume of solids by calculations is 7.59 cc's. Alright. Alright. Now the total volume, it's given. Before drying, the specimen was immersed in mercury and its volume was found out to be 24.26 cc. Alright. So yeah, I was wrong. Before oven drying, the sample has been subjected to the displacement test itself. After that, it has been taken to oven drying, just like the previous question. All right. So before drying, I missed this thing before. I thought it was after. Before drying, the specimen was immersed in mercury and its volume was found out to be 24.26 cc. So total volume V is equal to 24.26 cc. I need volume of whites. Since it is how much? Total volume minus volume of solids. This is the volume of whites. Volume of whites in this case will be total volume minus volume of solids. We know total volume 24.26 cc. Volume of solids I just calculated using this equation, 7.59. So volume of whites is 16.67 cc. And with the help of this thing, I'll be finding void ratio. Void ratio, it is volume of whites divided by volume of solids. Volume of whites is 16.67 cc. Volume of solids is 7.59 cc. So void ratio by calculations is 2.19. This is the void ratio. What else? Water content we have found. Void ratio. Now we need to find the degree of saturation. Degree of saturation is equal to Wg divided by E. So degree of saturation, water content, how much? The first thing that we found out was the water content, 70.12%. 0.7012. Specific gravity, question says we have to use specific gravity as 2.68. So 2.68 over here divided by E, void ratio, that's how much? 2.19. 2.19. So degree of saturation is equal to 85.80%. All right. So this is how we solve this question. We have found out all the parameters: water content, white ratio, degree of saturation, white ratio as well, everything. All right. So with this, we have completed this question. Moving on to the next one. Next question is, a sample of sand with a specific gravity of solid says 2.65 has a porosity of 40%. Find out the dry unit weight of the sample when fully saturated, submerged unit weight, and the bulk unit weight when the degree of saturation is 50%. All right. So let's once again read this question. I think a sample of sand with a specific gravity of solids of 2.65 has a porosity of 40%. Find out the dry unit weight of the sample when fully saturated. This is the first part. Then we have to find the submerged unit weight and the bulk unit weight when the degree of saturation is 50%. Let's solve this question. Porosity is given 40%. We can find void ratio using this formula. So void ratio is 0.40 divided by 0.60. It is 0.66. Alright, I'll be using this generalized equation ES is equal to WG to find the water content. So water content is ES divided by G. Water content is E is 0.66. S, a sample of sand with a specific gravity of solids is this, has a porosity. Find out the dry unit weight of the sample when fully saturated. Alright, and the submerged unit weight and the dry unit weight, the submerged unit weight and the bulk unit weight when the degree of saturation is 50%. Let me find the water content. Degree of saturation 50%. Specific gravity 2.65. Water content is 12.45%. Alright, let's move to find the part 1. It has these parameters. We have to find out the dry unit weight and the unit weight of the sample. Let's find the dry unit weight first. Dry unit weight as given by the generalized equation is this much. 1 plus E. So dry unit weight, a G, we have to use as 2.65, density 1 gram per cc, and void ratio 0.66. That means 1 plus E is 1.66. By calculation, dry unit weight is 1.59 grams per cc. Then I'll be finding the bulk unit weight as well by using this equation. Dry unit weight is bulk unit weight divided by 1 plus water content. Alright, so the dry unit weight is bulk unit weight, the parameter that we need to find. Water content 12.45%, 0.1245. This I have calculated. I'll be using this over here. 1.59 grams per cc is the dry unit weight. I'll be finding the bulk unit weight. All right. So by calculations, bulk unit weight is equal to 1.787 grams per cc. So I have found the dry unit weight and the bulk unit weight as well. What else do I need to find? Find out the dry unit weight, done. Unit weight of the sample, done when fully saturated. Submerged unit weight and bulk unit weight when the degree of saturation is 50%. Alright, so I need to find the submerged unit weight and the bulk unit weight. Alright, for that, let me find the saturated unit weight first. Saturated unit weight as given by the generalized equation is G plus E. So saturated unit weight is G, we have to use 2.65. Void ratio, I calculated 0.66. Density of the water is 1 divided by 1 plus E. 1 plus E, E was 0.66. All right, so the saturated unit weight is, by calculations, 1.99 grams per cc. If I know the saturated weight, I can very easily find the submerged one. Submerged weight is equal to saturated unit weight minus unit weight of water. So submerged unit weight will be saturated unit weight, how much? 1.99 minus unit weight of water, 1. So submerged unit weight will be 0.99 grams per cc. Alright, so we have calculated every parameter that the question demanded us to find. So we have completed this question by our respects. Now let's move on to the next one. Alright, the next question is, alright, 1000 cc core cutter. Alright, let's read out the question and then we'll be solving it as well. Alright, the question is, 1000 cc core cutter weighing 946.08 grams was used to find out the in situ unit weight of the embankment. 1000 cc core cutter weighing this much was used to find out the in situ unit weight of the embankment. The weight of the core cutter filled with soil was noted to be this much. Laboratory tests on the sample indicated a water content of this much and the specific gravity of soil solids as this much. We have to determine the bulk unit weight, the dry unit weight, void ratio, and degree of saturation of the sample. If the embankment becomes saturated, this is part second of this question. If the embankment becomes saturated due to rains, calculate the water content and the saturated unit weight. Assume there is no volume change in sample on saturation. All right, so let's solve this question one by one. All right, let's find the value of part first. Weight of the soil in the core cutter. How much is that? Weight of the soil in core cutter. How much is that? See carefully. 1000 cc core cutter weighing 946.08 grams was used to find the in situ unit weight of the embankment. The weight of the core cutter filled with soil was noted out to be this much. That means weight of the soil is this minus this, because this is weight of the core cutter filled with soil and this is the weight of the core cutter. So the weight of the soil is 2770.60 minus 946.80 grams. The data is very well given in the question. This much and this much. We'll be subtracting these two. We'll be having the weight of the soil in core cutter, which is equal to 1823.80 grams. Bulk unit weight, how much? Bulk unit weight is weight per unit volume. Weight is how much of the soil? 1823.80 and volume 1000, because 1000 cc core cutter was used. So the bulk unit weight comes equivalent to 1.823 grams per cc. Determine the bulk unit weight, the dry unit weight, the void ratio, and the degree of saturation. In the first part, we have to calculate the bulk unit weight, the dry unit weight, the void ratio, and the degree of saturation. I calculated the bulk unit weight. I'll be calculating the dry unit weight because I know the water content. Dry unit weight is bulk unit weight divided by 1 plus water content. Water content 10.45. This indicated a water content of 10.45%. So 10.45% is the water content. I have the bulk unit weight. I'll be calculating the dry unit weight. Dry unit weight is bulk unit weight 1.823 divided by 1 plus water content, that is 10.45%. By calculations, dry unit weight is 1.65 grams per cc. Next thing, I calculate a bulk unit weight, I calculate a dry unit weight, I have to find the void ratio. I'll be using the alternate equation for the dry unit weight to calculate the void ratio. Dry unit weight is equal to G rho W, G this, divided by 1 plus E. So dry unit weight is 1.65, specific gravity 2.65, density of water 1 gram per cc, and the void ratio that we initially calculated, it was how much? Void ratio, where did it go? It didn't go anywhere, we have to find it. All right, 1 plus E. So the void ratio by calculations is equal to, it is 2.65 divided by 1.65. So void ratio by calculations is equal to 0.60. All right, 0.60. What else do we need to find? All right, bulk unit weight is done, dry unit weight is done, void ratio is done. Degree of saturation. Degree of saturation. All right, degree of saturation is Wg divided by E. So degree of saturation, water content is 10.45%. G is 2.65. E we calculated as 0.60. So degree of saturation is 46.15%. 46.15%. With this, we very well calculated, or completed rather, the first part of this question. Now comes in the second part. Second part is, if the embankment becomes saturated due to rains, there is rains and the embankment becomes saturated, we have to calculate now the water content and the saturated unit weight, and we have to assume there is no volume change of this embankment or the soil sample that was taken with the help of a core cutter from this embankment, and there is no volume change in this sample as taken from the core cutter after rains or on saturation. All right, so let's solve this part. So when the embankment becomes saturated, S becomes, or the degree of saturation becomes 1. So the water content at S is equal to 1 is, we'll be using this equation, ES is equal to WG, or W is equal to ES divided by G. So E is how much? 0.60. Degree of saturation is 1. This is specific gravity is 2.65. By calculation, water content is 22.64%. So this is the water content after rains when the embankment becomes fully saturated. All right. Thereafter, one more thing that question demands us is to find the saturated unit weight. Find the water content and the saturated unit weight. Water content we have found. Now we will be finding the saturated unit weight. Saturated unit weight by using the equation. It is equal to G plus E, density of water, or unit weight of water, 1 plus E. G is 2.65, E we calculated 0.60, unit weight of water 1 gram per cc divided by 1 plus E. E is 0.60, so it's 1.60. So upon calculating it, saturated unit weight becomes 2.03 grams per cc. Part second of the question has been completed as well. All right. So this was the question based on the data taken from the core cutter test. All right. And 1000 cc core cutter was taken to find the in situ unit weight of the embankment. All right. So that's how we arrived at all the parameters, and that's how we completed this question. With this, we conclude this video. I hope it was helpful to you. Thanks for watching this video.